Hello, my name is Zachary Jones, and I am in 10th grade at William S. Hart High School. I created a fully functional half adder using pressure-driven microfluidics with the help of my mentor, Benjamin Gross. Here's a demonstration. As you can see, the water went out of the output channel of the XOR gate shown on the left and the drain of the AND gate shown on the right. This is expected for only one input. To make the gates, I first designed them in Inkscape, then printed them on these shrink ink sheets, then shrunk the shrink inks in oil, flattened them, taped them to the bottom of a petri dish, prepared PDMS, poured it over the shrink ink, pulled all the bubbles out of the PDMS in this degasser, then let the PDMS cure in the oven for 45 minutes. I then cut the excess PDMS away and laid it on a glass microscope slide that is wrapped in self-sticking silicone tape. Then put the chip back in the oven for 2 hours to strengthen the bond. It results in something like this. In our initial testing, we used these syringes. This was very error-prone, but it was useful for getting a qualitative analysis to see if the chips had a fighting chance. In our final testing, we used aquarium tubing like this, which you saw demonstrated at the beginning of the video. These are some of our initial gates. This is our initial OR gate, and it worked first try because it's just joining two fluid channels together. This is our attempt at a NOT gate, which failed miserably. You can check the report for more details. These are our initial XOR gates, which also failed miserably. Again, you can check the report for more details. And these are our initial AND gates, which worked, but they were very temperamental, so we decided to improve them. These are some of our improved AND gates, and we eventually landed on this design, which I'll get into in a bit. Somewhere along the line, we realized we could make an XOR gate by modifying the AND gate, and that's what these are, prototype XOR gates. We eventually landed on this design, which I'll explain in a moment. This is the final AND gate. This is a graph of the accuracy for each iteration of the AND gate. We eventually got it to 99.2% accuracy. The AND gate works because these top two are the input channels, and then these bottom two are the drains, and then this vertical channel is the output. So if water goes through one of the input channels, then it goes straight past the output channel and goes through the drain. If water goes through both inputs, then the water streams collide and they push each other into the output channel. The XOR gate is basically just the AND gate, but in reverse. These two, and this is the graph of the XOR gate accuracy for each iteration. We eventually got it to 96.7% accuracy, which I think is as good as we can get it with our equipment. This XOR gate is the opposite of the AND gate. The output channels are here and the input channels are here, and this vertical channel is the drain. If water goes through both input channels, then they collide and send each other down the drain without going through the output channels. And if water goes through only one of the input channels, then a lot of it will go down the drain, but some of it will go out the output channel, which is what we want. This is our final half adder, which we made by just combining the AND XOR gates with two inputs. Our half adder had 93.3% accuracy, and this is the chip graveyard of all the chips we've ever done. Thank you for considering my project.